All right, now let's talk about all four of these numbers: hydronium, pH, hydroxide, and pOH. So the more acidic something is, the lower the pH is, the higher the hydronium ion concentration is. The more basic something is, the higher the pH and the higher the hydroxide ion concentration is. We can go to some extremes if you look down here and look up here. Now the pH scale usually goes between 1 and 14, and that has to do with that 10 to the negative 14th from our kW. But sometimes we can get extremes where we have something that's incredibly acidic or incredibly basic. So sometimes we can get a negative pH or a pH that's above 14. Now we have this pH loop, so we can go around it to get to anything. Let's say I have hydronium, but I want pOH. So I can use pH, negative log of H plus, to get to pH, and then pH plus pOH equals 14. So then I can do 14 minus pH to get to pOH. Okay? Or actually, no, let me leave that circled. All right? Same thing. I have H plus and I want pOH. Well, I can use my relationship from Kw to get hydroxide, and then I can do negative log of hydroxide to get over to pOH. It doesn't matter which method I use, I'm still going to get my pOH. Okay? Let's say I have hydroxide and I want pH. Same thing. I can do negative log of hydroxide, get pOH, and then 14 minus pOH gives me pH. Or I can do Kw and go from hydroxide to hydronium, and then pH calculation with that negative log. Okay, so we can go around the loop in whatever direction we want. It's equally valid. Okay, you can take the black path or the green path. It doesn't matter. They're both going to get you to the same spot with the pH.